Welcome back to your Algebra 1 Semester 1 final review. We're looking at problem 42, which gives you a system of inequalities again. Um, I'm going to give you two different ways to solve this problem. The first way is probably the faster way, and then I'll show you the other way in case you don't like the first way. So the first way, what we're going to do is go through and actually graph this system of equations. Now, when we graph this, the first thing we're going to do is graph the boundary lines. So the boundary lines for a system of equation or a system of inequalities look exactly like the equations, but instead of a greater than or a less than sign, they're just equals. And so I'm going to try to show these in two different colors. Okay, so let's get these boundary lines done. Y equals -4, nothing too terrifying there. There's a y-intercept of -4. And because there's no x, there's no slope. Lines with no slope just go straight across, horizontally. So here's my horizontal line. It's a solid line because in the original there is an equal to. And now we're on to the second one. To graph that 3x minus 6y equals 12, we're going to use my favorite trick of finding x and y intercepts. So as a reminder, to find your x-intercept, we need there to be an x in the equation. We're going to find an x value, but we don't want there to be a y. We're going to replace y with 0. So that's going to be the equation 3 times x minus 6 times 0 equals 12. But what really happens is the part with the y just cancels out and leaves us with 3x equals 12. Solving this isn't bad at all. Just divide by 3 and we get an x-intercept of 4. 1, 2, 3, 4. Doing the y-intercept is really the same thing. You'll notice that the y canceled out when we were solving the x, so it shouldn't surprise you too much that when we find the y, the x is going to cancel out and just leave us with -6y equals 12. Then we're going to divide off our -6 and gives us a y-intercept of -2. From here you can see your slope. It looks like we go down 2 to the left 1, 2, 3, 4. And so we'll continue this on out. Down 2, left 1, 2, 3, 4. Down 2, left 1, 2, 3, 4. And that should give us enough to make a decent line through all of our points. But be careful, because we don't want this line to be solid, because our equation says the left side is greater than 12. If the line was solid, that would mean that the points on the line would be equal to 12, and we don't want that. So we're going to go through and just dash our line here, just to show that it can't be equal to the line. At this point, you should notice that we have 4 different spots on our graph, and I'm going to label them quickly and then erase it for clarity in a second. We have one spot here, another here, another here, and then this itty little bitty spot for 4 over here. Only one of these spaces is going to be shaded in. Whichever space is shaded in is going to contain all of the points that are solutions. So how do we figure out where to shade? Well, that's actually not too bad. We're just going to go ahead and pick any point we want and try it in each equation. So any point we want, well, let's actually just take one of these answers over here and try one of those. For example, what if I took the point 1, -6? Let's see, that's over 1 and down 1, 2, 3, 4, 5, 6. That's way down here. Okay. Now, if this point works in each one of these equations, that means that we're going to want to shade where that point is. However, the easiest way to do this is really pretend like you only do one equation at a time. So I'm going to erase this and then put it back in just a second, but I'm going to erase my purple line right here and pretend like there's only the blue one. So all I'm going to do is take this point, 1, -6, and plug it into my blue equation, which was y is greater than or equal to -4. Now, we have an x and a y in this point, but my equation only has a y, which is nice. It's less work for us. It means we need to replace the y with what it is in the point. It looks like in the point it's -6, and then we just need to see if our answer is true or false. So, is -6 larger than -4? Hopefully you're saying no, -6 is not larger. This is false. So the point that I tried here was not the right point for the blue line. Instead, this point if it didn't work on this lower side, would only work on the upper side. And it shouldn't surprise you because our equation says the y's have to be larger than -4. All the y's that are larger than -4 are the y's up here. So what I'm going to do, because the green point didn't work, is I'm going to point some arrows the other direction from the green point. And that's just telling me that if I just had the blue line, I would shade all of this in. Now, if the green point had worked, I wouldn't have put arrows there and we'd put arrows down the other way. But it didn't work, it was sad, it was false, and so we're going to shade above the blue line where all the points are that do work. But don't forget, we didn't just have one line, we had two. We had this dashed line that was coming up here as well. So this dashed line, we want to forget for a quick second that this blue line was even here. And we're going to try that same point though. I'm going to try 1 -6 into the other one, which was 3x minus 6y is greater than 12. That means that I have now an x and a y that I'll need to replace, where my x is 1 and my y is -6. And let's see if this works. This becomes 3. -6 times -6 is positive 36. Adding those gives us 39. Is 39 greater than 12? Well, yeah, actually, I think 39 is greater than 12. That's good. That means that our green point here worked for the purple line. So my purple, I want to point arrows towards the side that has that green point. Now, don't forget, we did have two equations here, and I'm going to go through and put the other one back. This blue one had arrows that were pointing up. And now, we need to finish off. Now, if you had two colors, this would be pretty easy to see, because the blue one would be colored like this. We would go through and we would shade everything here with blue. And then the purple one would be shaded like this. The purple would be shaded on this side. And our answer would be wherever the blue and the purple overlap. However, the reason we went through and drew arrows is to try to cut down on all this weird different colored shading that's going on, especially if you don't have colors. All we're looking for then is in these 4 zones, and again I'll remind you of those 4 zones, they're right here. Where do the arrows point to each other, or where is the shading in the same spot? And you should notice that that occurs in zone 2 over here. So that means that my final answer needs to be in this little section. Now, that doesn't look like an answer. I don't see any shading over here. So how did that help us? Well, by shading that spot, that's telling us where all the points are that work in both equations. So now we're just going to take a look at our 4 answers and see which one of those points falls within the green shaded region. We know 1, -6 doesn't. That's way down here. That was a no-go. What about 6, 1 over, and we should do this in maybe a darker color, over 1, 2, 3, 4, 5, 6, and up 1. That's really close. I'm not sure if that works or not. So let's try a couple others. -3, 1, 2, 3, up 2. Well, that one definitely didn't fall in the zone. And then what about over 1, 2, 3, down 2? Well, it looks like it might be one or both of those, and this is an ABCD question, so it can only be one. I'm pretty confident that it's going to be 3, -2. That's pretty smack dab in the middle of that zone. But let's see why it couldn't be 6, 1. The other way that I mentioned that you could have figured this problem out without graphing is you could have done this method right here. You could have tried every single one of these points and plugged them into each equation and just wait to find the equation that works with both points, or the point that works in both equations. So let's try 6, 1. I'm pretty confident that if I plug 1 in for y, I think that 1 is definitely larger than -4. So easy enough there. However, what happens when I plug 6, 1 into this equation? So x is 6, y is 1, and we need this to be larger than 12. We've got 18 minus 6 is greater than 12. 18 minus 6 is 12. We get the same number on each side, which normally is what we're looking for, but this isn't an equation. This says 12 is larger than 12, and that's not true. 12 is not larger. 12 is the same, but not larger. Whenever you get the same number on each side, what that's telling us then is that this point that's right here, this point landed on the boundary line, right on this dashed or dotted line. And because there's no equals, points on this boundary line don't work. Now, if the point had landed on the blue boundary line down here, we'd be good to go because blue is solid. We're allowed to be equal to that. But it didn't. It landed on this upper one, which is not a good point, and therefore we find our final answer is D.